A polynomial function can have either real zeros or complex zeros, or a combination of the two. But according to a theorem, a polynomial function cannot have more real zeros than its degree. So if we have a fourth degree polynomial, we'll have at most 4 real zeros. The rule of signs can be used as a guide to help us identify the number of positive real zeros that we can expect to find, as well as the number of negative real zeros that we can expect to find. It's important to keep in mind, though, that the rule of signs in many cases can be more of a guide rather than a tool that gives us explicit results. And we'll see why that's the case as we look at a few examples here. In example 5, in part A, we're asked what the maximum number of real zeros that this function can have is. Since this is a 7th degree polynomial, that means its degree is equal to 7, so at most we can have 7 real zeros that would occur. In part B, we're asked how many positive real zeros the function can have. To answer that, we'll turn to the rule of signs, which tells us to look at the original function and count how many times the sign changes from term to term. In this case, we get one change from negative to positive, a change from positive to negative, and a change from negative to positive. So we get 3 sign changes, which tells us that we can have 3 positive real zeros or an even integer less than that, which can be a confusing statement. But what it means is we start with whatever value we come up with, which is the number of sign changes, and we continue to subtract 2 from that until we get down to 0. So we'd start off with 3, subtract 2 to get 1. If we subtracted 2 again, we would be past 0. So we'll stop there. The rule of signs then tells us that this function can have either 3 or 1 positive real zeros. In this case then, this isn't a definitive answer. We have one of 2 different possibilities, but it is something that we can check our final results against to make sure that however many zeros we come up with, we have exactly 3 or exactly 1 positive real zero. If not, we've made a mistake somewhere. To apply the rule of signs to tell us about the negative real zeros in part C, we need to start off by evaluating f of negative x, which in this case would become 3x to the 7th power, minus x cubed, minus x squared would remain unchanged, and plus 9 would remain unchanged. Then we apply essentially the same idea that we did in part B. We count the number of times the sign changes, which in this case now is only 2. That means this function can have either 2, or if we subtract 2 from that, we get down to 0, negative real zeros. Again, we don't get a definitive answer, but we do have a guide that we can check our final results against to see if we're on track with our expectations. In example 6, we want to apply the same idea. We're asked the maximum number of real zeros. In this case, that would be 9, since we have a 9th degree polynomial. The number of positive real zeros, in this case, would be 0, because as we look at g of x, there are no sign changes. If we evaluate g of negative x, we'll get negative 4x to the 9th, plus 8x to the 8th, plus 2x to the 6th, minus x, plus 8. This means that now we have 2 different sign changes occurring. So we can have either 2 or 0 negative real zeros occurring for this problem. I'm sorry, let's go back. I actually missed one. So from negative x to plus 8, we get another change. So we could have either 3 or 1 negative real zeros occur for this function. In example 7, again, the 3 same questions. We can expect no more than 8 real zeros, since this is an 8th degree polynomial. Applying the sign test to the original function, we see 1 sign change, so we can expect 1 positive real zero. If we evaluate h of negative x, we get 2x to the 8th minus 1. We still have exactly 1 sign change, so we would expect 1 negative real zero. In this case then, for example 7, we do get more of a definitive answer. In finding the zeros for this function, we know that we would get exactly 1 positive real zero and exactly 1 negative real zero. Still doesn't tell us what those zeros are. We'll build on how we find those. But again, this is the idea of how we use the sign rule, or the rule of signs, as a guide for checking our final results. We want to compare them against the possibilities that we came up with before to make sure we're in line with those expectations.